Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see some of the basic and arithmetic operations on images using OpenCV. So let's get started. So here I have this code. Some of this code you already know. So you already know how to read the images using img method and then show it inside a window using imshow method and destroy all windows using this destroy all windows method. But this code in between is a little bit new. So let me explain line by line what this code does. So when you have this image using img method or any other method, you can use these attributes like shape, size and dtype to get different values from this image. So img.shape is going to return a tuple which contains the number of rows, columns and the number of channels in this image. The img.size will return the total number of pixels which are there inside the image, and img.dtype is going to return the data type of the image which you have obtained. Now here, if you want to split your image in 3 channels, then you can use cv2 split method and pass your image as an argument, and it's going to give you the BGR channel of your image. Now if you have BGR channels and you want to merge those BGR channel into an image, then you can use cv2.merge method and pass these BGR channels in the form of tuple, and it's going to give you the image which you can load using imshow method. So let's run this code and let's see what we are getting using these attributes. So you can see this messy5.jpg image is loaded, and here you can see first of all the shape of the image. So the shape returns the number of rows, number of columns and the number of channels. So number of rows here is 342, columns are 548 and number of channels are 3 here. The number of pixel which we have calculated using the size is this number, which is 562248, and the data type of an image is uint8. So sometimes you need to debug the data type of your image, and this attribute will be very useful in those cases when you need to debug if something is correct or wrong. And because we have splitted this method using this split and re-merged these BGR channels using this merge method, so we will at the end get the same image which we have at the beginning here in this code. So there is no change in the code. So once again, let me just load this image, and now let's talk about the ROI of an image. So ROI stands for region of interest. So sometimes you need to work with certain region of the image. So let's say you only want to work with the face here, or you only want to work with this ball. Okay, so this is called the region of interest, or in short form it's called ROI. So let's say we want to just work with this ball here. So this will be our region of interest or ROI, and I want to just copy this ball to other place in this picture. So I want to just copy this ball and place it on the other place, let's say somewhere here. Okay, so how we can do this? So I already have the coordinates of the ball, but you already know how to get the coordinates of some place in the image. We have already discussed this in our previous video, so I'm not going to show you how to obtain those coordinates. But let's say I have those coordinates of the ball, so I'm going to create a ball variable, and we have our image. So we will take our image, and there are certain Numpy indexing features which we can use here. So I'm going to just write 280 colon 340, which is going to give you 1 point on the ball, which is the upper left hand side of this ball. And then we will give 330 here colon 390, which is going to give us the bottom right hand corner of this ball. Okay, so now we have this ball. So this indexing is going to copy this ball, all the pixels of this ball, and then now we have the ball, so we can place this ball on any place on this messy image which we are reading. So what we can do is we can once again use img, and using those Numpy indexing features, we can place this ball at some other place. So let me just give those indexes here. So let me give 273 colon 333. I have already tested this code, so that's why I know exactly where I want to place this ball. But if you are not sure where to place this ball, then you might have to first calculate or know the coordinates where you want to place this ball, and you already know how to find out the coordinates on an image, and you will be able to place that ROI or interest of region at some other place. So what I'm doing here is I have just copied the ball, and then I am placing the ball on this coordinate. Okay, so I just need to just assign our ball on this coordinate, and then this ball will be copied to this index on the image. So let's see what happens when we run the code. So now you can see we have copied this ball, and we have placed this ball here on the image. So this is how you work with the ROI or region of interest. Okay, so let me close this window. Now the next thing which I want to show here is how you can add two images. So for that I need one more image. So you can see in my project I have this messy 5.jpg, and I have this other image which is OpenCV -logo.png file, which is of the same size as the messy.jpg image. So I'm going to just write img2, and then once again cv2.imread method, and then I'm going to give the name of this file, which is OpenCV -logo.png file. Okay, so this is this file. So this file we are reading, and then there is a method called add. Okay, so we are going to use this method here. Let's use this method cv2 dot add, and this method I'm going to show you what it does in a moment. But this method takes two arguments. First is the first Numpy array. So let me show you what this method do first of all. So this is the add method inside your cv2 package. You can also see the documentation on the OpenCV.org, and what it does is it calculates the pre-element sum of two arrays or an array and a scalar. Okay, so here we can just pass our two arrays which we got from the imread method and pass here as the first and the second argument. So img and img2 are the 1 and 2 parameter, and there are some other parameters also like output array, input array mask, and int, which is the data type, which are set by default, so we are not going to set them. So we are just using cv2.add method on these two images, and then I just want to assign the new image which we have added to a new variable. Let's say this is dst for destination image, and then we are going to just show this image using this img.show method. Okay, so we have two images. Let me show you those images one by one first of all. So this is the first image I have, and the second image is OpenCV-logo, which is like this one. Okay, so those two images we have, and when I run this code after adding those two images using add method, you will see, first of all, you will see this error. And why this error is coming? Because you will see here that the size of those two input is not matching. Okay, so in order to add two images, you need to have the images or the arrays of same size, and then only you will be able to add those two images. So let's resize those two images into a size which is common to both of them. So what we are going to do next is we are going to resize those images. So once again, I'm going to just use img variable. So what I get after the resizing, I will once again assign to this img variable, and there is a method called cv2 resize, and this helps us to resize the image. So first of all, we need to give the source which we want to resize, and then we are going to give the size which we want to get. So the number of columns and number of rows we can give here. Let's say we want to just resize this image to 512, 512, which is the number of rows and number of columns, right? Same we will do with the next image. So img2, and then once again cv2 resize, and then the source here will be image2, and the size which we want here is again 512, 512 in the form of tuple. So we have resized this image and this image, which are of different sizes, to the same size. And now let's run the code once again, and now you will see that these two images are merged now. Okay, so you will be able to see the hand here and little bit foot, and here the ball of this image 1, which is messy 5, and then we have the second image, which is OpenCV, which is added to the first image. So this is how you can add two images using OpenCV. Now there is one more method which is called add weighted. Okay, so this add method is going to just add these two images, but if you want to add the weight, for example, you want to give the weight 90% to the first image and 10% to the second image, there is one more method. So let's go to the documentation once again, and there is this method called add weighted method. Okay, so this add weighted method takes several arguments. Here you can see first is the source of the first array, and second argument is the alpha value. Alpha is the weight which you want to give to the first image. Okay, the third argument is the source 2, so in our case this will be the image 2. The fourth argument is the beta. Beta is the weight which you want to give to the second image, right? So this weight you can give from 0 to 1, anything. And this gamma is the scalar value which you want to provide, and this second last parameter is the destination, and the last is the dtype or the data type here. Okay, so this is the formula which this method is going to use. So source multiplied by alpha and source 2 multiplied by beta plus gamma. So this is the method which will be used using these arguments, or simply you will use this kind of method. So source multiplied by alpha plus source 2 multiplied by beta plus gamma, which is the scalar you can add to the image. Okay, so let's use this method. So I'm going to just copy this method and then comment this and go to the next line, and instead of using add, I'm going to use the add weighted method. Okay, so the first argument is the source, which is the first source, which is img in our case. Second argument is the weight. So first, this is the messy image, right? So we want to just give the weight here 90, or you can just give 0.9 here. And for the second image, we want to give the weight 0.1. Okay, so the sum of this weight and this weight will be 1. And also we are going to give the gamma value here as 0. So we don't want to add any scalar value to this add weighted method. So the next value here will be 0, which is the value of gamma. And let's run this code, and you can see now we have our messy image, which is dominant here because it has the weight 0.9, which is 90% of the 2, and the OpenCV image have the weight 0.1, which is 10% of the 2. Okay, so the OpenCV image is light and the messy image is a little bit dominant here. You can just give 0.5 and 0.5, so the weight of the two images will be the same, and now you will see those two images in the same domination. Okay, so 50-50%. Now let's say we want to increase this value of OpenCV to 0.8 and the messy image weight will be 0.2. Then the dominant image here will be OpenCV, and in the background kind of thing you will see this messy image. So this is how you can add two images with their weight and the scalar. And that's it for this video. So in this video you have seen some of the basic operations on the images and some of the arithmetic operations on the images which you can do using OpenCV. So I hope you enjoyed this video, and I will see you in the next video.